So hacksters are back again, guys. So let's dive in right now. So the thing is, this time we have implemented almost every deep learning model that we have planned to do in machine learning. We have trained all the model, and we are serving almost 6 of them in the browser. And for the implementation part, you can see that in Vishak's video, and in this part we'll be discussing only the PPT. Okay, so let's start. The product we are providing, which is named as VirtualDoc, we also like to call it as doctor in browser. So let's move forward. Okay, so what's the problem statement? So in the website, the organizers have said that there are almost 8 tracks over there, and from them we have targeted the healthcare track. And in the healthcare track, they mentioned that the thing is, the main problem statement is people are not able to get the medical services very quickly, as the patient and doctor ratio is very less, and except that sometimes getting a doctor's appointment costs so much, so sometimes people cannot afford that. So the problem statement is to make that affordable and quick. So to do that, what we have done is that we have trained bunch of machine learning model, like cancer detection, like malaria detection, like pneumonia detection, and even COVID detection. Okay, so we have done all the stuff, and we are going to provide all the thing in the browser, and user can go there and give the input and get their subject. Okay, so to do that, the technology that we have used, so for the web development part, we have used Node.js, Express.js, React.js, MongoDB, and TensorFlow.js. And for the machine learning part, deep learning part, that using we have trained all the model is TensorFlow, Pandas, NumPy, and OpenCV, and Matplotlib. Matplotlib is not required, but just for visualization part. So let's move forward. And this is our services. This is the bunch of 8 services that we are going to provide for right now, which is cancer detection, diabetes detection, malaria detection, pneumonia detection, heart disease detection, liver disease detection, kidney detection, and COVID detection. Okay, so this 8 stuff we are going to provide. We have trained all these 8 models, but for now, as because of the time constraint, we are going to provide only 6 model in the browser for user to go there and do all the stuff. Okay, and this is the accuracy that we have got. This are like baseline models, we can say. Like, I have not hyper tuned everything, and we can do bunch of stuff with that models to get that accuracy higher. But right now we have COVID detection with 96.5%, then malaria with 93.39, then liver disease detection, which is 71.64, cancer detection, which is 70.17, diabetes is 70.17, and kidney is 62.5 right now. Okay, so like we are what we are, right? So how you can distinguish our team, our product from others, right? So there are 3 points we want to mention. Like, there are the model where we have made that you have seen, which is in 90s and 70s and 80% accuracy, which is pretty much good for as a baseline model right now. And except that, we are going to provide medical assistant, which will be like, if someone gets detected, then they can get the nearby pharmacy or medical stores email address, and they can book their appointment with the doctor for further medical assistance, and like any kind of diet they have to maintain, or any kind of medicine that they require, and they can do that. And except that, availability and more service, right? So we will be providing badges to the people who are checked as a negative, so they can show that in share that in their social media platform and stuff. And there are other also, like we are planning to add chatbot stuff, so that will be coming up, right? So this is what we have planned, that we have done. So more stuff is coming up with the Vishak's video. So he will be showing all the implementation that he have done in the browser itself. So stay tuned. Okay. So there is a team. This is the team of three: Vishak, again Vishak, and Somodeep. So we are doing the whole stuff all by ourselves. And thank you for watching the video, and stay tuned for Vishak's video. Okay.
So my name is Vaishak, and I'll be presenting the actual implementation of the project. So this is the landing page where we are given a short description about the different different options that we give to the end users, and there's a sign up and login, sign in and sign up page, and there's also a short description about us regarding the about our team, and like there's an option for sign up where the basic details about the user would be taken, and we have actually done all the validation part for the validation, or the for the registration for registration and login part. We have already included the whole validation part, so it's working fine. So for this video, I have actually created a user. So yeah, I'll try logging in. Yep, this is the actual dashboard. So here we have actually implemented six different diagnostic options for the end users. So we had actually planned for eight features, but we could only complete implementing the only the first six of them. Other than this, we had actually planned for breast cancer detection and also pneumonia detection based on X-ray scanning. So of these six data, we have four of them are tabular entry based, and two of them are image based. Of these, the image based detection methods are COVID detection and malaria detection. And I'll just give a sample working for working of two from each of these sections. So first of all, kidney diagnosis. So for this part, I had actually, I had made use of for training all these models. I had made use of our team had made use of Kaggle datasets. So this is the data from the actual uh, Kaggle dataset. So I had actually run the code earlier, so the Google Chrome is actually suggesting the recent values. So I guess it's much better way to show the implementation as soon as possible. So I'll go in. Let me check. After one, it's kidney. After 36.0, 1.2, 1, 1, 0, 1.0. That's one. 80. We see age is here. 80. 0.048. And on final submission we get the actual result. So after that on clicking the submit button, the actual data is being passed from the React side to the React is actually calling an API request with the Node.js server. So the Node.js server has been implemented in such a way that we have made use of the TensorFlow.js library, which actually, makes use of the. We have actually my teammate Somideep has actually implemented all these training. He had done all the training in Python, and he had actually extracted the weight files. So these weight files I am actually implementing. I'm actually using these weight files in the Node.js backend, uh, and thereby predicting the outcomes. So I have used TensorFlow.js library for this prediction part. So the Tableau data gets passed to the Node.js backend, after which gets is given for prediction, and the actual result is given returned back. So based on we have actually made use of the classification threshold of 0.5. So if the value is 0.5, or if it is greater, based on whether if it is greater or lesser, we actually show the results. It's a basic classification algorithm. So this is the result for the kidney part. I'll show one more regarding the liver disease detection. So here also I have, let me check, liver age 65, and for this gender part and all, we could actually I mean, the main thing that we had during the hackathon was the time constraints. So for this gender part and all, we could actually in the future we could actually change it to male or female, and thereby we could actually do the string parsing, and thereby come up with then I mean, the UI could be much more improved. Rather than 0 or 1, we could actually give the value of what is it, give the actual values, male or female. 6.8. Here also the actual result is returned after, I mean, as I just mentioned, the data is given to the Node.js using an Axios API call, after which the result is returned. And that's so now that I have shown, I mean, two of the sample data. Now I'll sample results of tabular data. Now I'll show you uh, for image data. So this is for malaria detection. So I'm going to choose one file that the images are actually are of the form of JPG format. Malaria, yeah, this is an infected data. So I'm going to submit it. Yeah, sorry, you have malaria. So this area was somewhat little much tough with like implementing the converting the images to NPRAs in the form for model prediction was a little bit tough. But yeah, this was one area which we had to dedicate much more time. So that is the case. I'll show the results for a data which doesn't have which is uninfected. Yeah, that's it. The all the code implementations are available in GitHub. We'll also share the GitHub repo link to the with this final submission. Same is the case for COVID detection. We could actually choose one file. Here it is. I'll first go with COVID data, and sorry, you have code. That's it. The same ideology. We have actually trained the model, so it's just normal prediction, normal classification algorithm, and yeah, that's the overall idea. So the main idea behind this project is to bring all these different detection or diagnosing techniques to a unified portal. Like most of these, we know that these data exist, these models exist, but uh, for the end user, it is not accessible. Like from a data scientist point of view, we can actually train the model and come up with a solution, but it's not feasible for I mean, for the end user. Like they won't be knowing much more about this training, and also we have actually plan of making use of this portal as an interface for the end user who doesn't have any technical skills to actually um, uh, make it easy for them to get detection or diagnostic results from the lab results or from the data that they have. So we plan to actually we furthermore plan to include some more detection techniques, and also based on what is it based on the we could have actually tried to improve the accuracy by researching much more into the different architectures that we had used for the model training part. So as my teammate would have explained in the PPT, you would have seen the different like what is it different accuracy percentages. So we could actually try to improve that after once this project is over. We could actually build upon the base that we have created and come up with a much more better product. And one more thing, for the profile out, we haven't completed it actually. For what we were planning actually to, I mean, since we have implemented the login and register features, we were actually planning to create a portal where the user would actually look back at his previous results. Like in the case of diabetes and things like that, they could actually look back to their previous results and keep a track of their data. So we weren't able to complete that feature due to time constraints. But of course, after submitting this solution, we would most probably will complete. We are much more bound to completing this project. So that's all from now. That's all from me. Thank you.